Hello everyone, this is Jeffy Jebastin. Today we're going to be seeing the 8th experiment of our Linux and Unix lab. So today we're going to be dealing with the various system calls which are used in process such as fork and um, wait, sleep. So all of this with regard to process creation. So let's get started. The first program is to create a process, and from the parent process we're going to prompt the user to enter the number of seconds, and from the child process we're going to segregate that into hours, minutes, and seconds. So here we go. Even as we're writing this code, just to remember that um, we are doing the first process, which is the parent process. So once we enter the main function itself, it is the parent process. So we have three variables, namely seconds, minutes, and hours. And the parent process, we get PID is to get the process ID of the parent. Um, then enter the seconds, and the user is going to enter the seconds. Then we're going to take in the fork. We are initializing the fork to PID, and if PID equals 0, then the child process is always going to have a process ID of 0, and the parent process would have another number. So if PID equals 0, it means that you've entered into the child process. So child process and the child process ID, parent process ID, which is get PPID, and then to get the hours we calculate by seconds by 3600. To get the minutes, it's seconds modulus 3600 divided by 60, and seconds it is minutes modulus 60 divided by 60. Then we segregate this into hours, minutes, seconds, and get the output and display it. So this is the end of our first program, and our second program is going to include we have to display the reverse of a string. So I'm using three header files, which is string.h, stdui.h, and unistd.h. So inside our function, the main function, we have a character string 1, and int I j, which is equal to 0. J is initialized to 0. So in the beginning we have the parent process. To get the parent process ID, we use get PID and then enter the string. So this string is taken, and I'm using another variable L to get the length of the string through string length. That is why I've used the header file string.h, and then I'm printing out the string length. Then the fork. PID is equal to fork. If PID equals 0, then this is again the child process. So inside the child process we're printing out the child process ID, the parent process ID, and so this is a simple logic, which means that as long as I is greater than half of it and j is less than half of the total length, just keep reversing the string. So the string is reversed and it is made to appear. So otherwise, if not, then PID again is equal to fork, and then PID1 equal to, if PID1 equal to 0, then process ID is printed, the parent ID is printed. Then I'm comparing the strings to check if it is a palindrome. So it's basically A has two children, B and C. In B we are checking the reverse the string, and in C we are checking if it is a palindrome. So this here we're just checking if it is a palindrome. So if string 1 equals, like compare string 1 and string, if both are equal to 0, then it's a palindrome, else it is not a palindrome. So then sleep. Then we have the third program. Now the third program is factorial. So here, as you can see, we have declared two header files, which is just types.h and stdui.h, and in void main, that is the main function, we have the initial parent process A with id, get PID. So this is printed, and then enter an integer. An integer is entered by the user, and then PID contains fork, and if PID equals 0, then process B, which is a child process, is created. So the parent process as well as the child process ID is printed. So if so here we again have int I and f equals 1. So this is a factorial. So the logic of factorial is followed. So I equals 1, I less than or equal to n. N is the integer that we have taken from the user previously, and I plus plus. So f equals f into I. So factorial of number is going to be printed here. Then I have another fork process which is for the next child now. Then process D is created now, and in then I'm going to display the parent process ID and the child process ID as well. Now in the Fibonacci series, as you can see, we have two other variables, which is a equals n and x equals a. So b equals c 0, c equals 1, and d. And in Fibonacci series, the usual logic is followed. While x minus 2 is greater than 0, d equals b plus c. So we are interchanging the variables, the values inside the variables, decrementing the value until this condition is true. It will keep going again and again. It's a loop. Then it will come out finally and sleep. Now here we have for the process C, we have another process ID. So process C is created, then the process ID of the parent is printed, the child is also printed, and then we've got to check whether the number is an Armstrong number or not. So the logic for Armstrong number is followed here, wherein while on is not equal to 0, on is moduli 10, and then it is multiplied, the cube of r is found out, and then it is divided by 10. So if res equals n, then it is an Armstrong number, otherwise it is not. So then next we have the process E. So here the process E, we have the process E, and then here we use the logic to check if it is a prime number. So to count and to print how many number of prime numbers we have. So we use this logic, which is just two for loops, and then sorry, it is a single for loop. Inside the for loop we have an if. So if this is equal to 0, then C plus plus, which means that it is an even number. Then if c equals 2, then it is a prime number. Then for anything else, it is it is not a prime number. So here we have the next process, which is f. The child process, the parent process ID are printed. Here we have the reverse of a number. So we're just going to first modulus the number with 10, and then multiply with 10, and then add with the previously modulus number, and then divide it by 10, and we get the reverse of the number, which is then displayed. So with this we complete the 8th experiment of our Linux and Unix lab. Thank you.